Okay, guys, we're going to look at section 5A here, which is linear equations. And let's go ahead and get started right away. It says a rental car company charges a base fee of $39.41 plus 58 cents per mile driven. X represents the number of miles driven, which of the following equations could be used to find Y, the total cost of the bill. So they're charging this $39.41 plus 58 cents per mile. X is going to stand for the miles driven, and Y is what we're trying to find, which is the cost of this bill. All right, so let's take a look. Y being the cost, or Y also, couldn't we say cost is what they are charging? So what they are charging Y is, well, they're telling me right here what it is. It's $39.41. It's $39.41 plus 58 cents per mile. We've talked about this a lot this year. The word per is referring to a rate of change or a slope, which always goes beside a variable. So 0.58 per what? Per mile. Well, per mile, oh, that's what X is the miles, or per X. So it's $39.41 plus 58 cents per mile, or per X. If I look at the equations that I have down here, this first one here is exactly the same, other than the fact they switched the order and they wrote it in slope-intercept form with the slope first and the intercept second. But it's the same equation because remember, with addition, it doesn't matter which order we add. All right, let's take a look at the second one here. A little bit more involved here with this problem. It says Leanne leaves town traveling an average rate of 55 miles per hour. After 3 hours, Bart leaves town traveling the same direction at an average speed of 77 miles per hour. So here we go. Leanne is going at a rate of 50, a speed or rate of 55 miles per hour. Bart is traveling at a speed of 77 miles per hour. And it says after Leanne's been gone for 3 hours is when Bart finally leaves town. They're traveling in the same direction. Which of the following equations could be used to represent the distance between Leanne and Bart after X hours? So we know X represent our number of hours. Let X represent the time in hours. We already talked about that. And that Bart has been traveling, Y represents the distance between the two of them. All right, well, first of all, Leanne has a head start. So let's figure out what the distance between the two of them is going to be right out of the gate. Leanne's traveling at a speed of 55 miles per hour. And she's traveled for 3 hours before Bart ever takes off. And remember, we talked about the unit we want the number of miles between them goes on the top of our ratio, and the units that we want to cancel out will go on top and bottom. And when we do this, we see that we're going to multiply. Well, if you take that 55 times the 3, we end up getting the distance between them at this point is 165 miles. Now, let's start our equation. What does Y represent? Y represents the distance between. The starting distance between, after Leanne's had this 3-hour head start, is 165 miles. Now, at the 3-hour mark, after she's been gone for 3 hours, Bart now takes off. And I think it's appropriate to talk about Leanne and Bart's speed, because Bart is traveling at a faster speed. And why don't we go ahead and put Bart, that's fine, we'll leave it like that. Bart is traveling at a speed or a rate of 77 miles per hour. Leanne is traveling at the speed of 55 miles per hour. So if I take a look at those, and subtract them, that means that at a rate of 22 miles per hour, Bart is going to catch Leanne by 22 miles every hour. Okay, so I subtracted the two rates, and 22 miles per hour is the rate in which he's going to catch. So the distance between them is going to decrease by 22 miles every hour. So the 165 miles is the distance between them minus 22. But not just minus 22, it's minus 22 per hour, and representing the hours or the time is our x variable. So 22 miles per x. So the distance between them is 165 miles minus 22 miles every hour they travel. And in the end, your final equation here would have to be D. All right, looking at the next one. Ann is moving from Houston to McKinney and rented a truck from You Move Truck Rentals. The cost of a one-day truck rental is given by this equation. And ooh, as soon as I see that, oh, this is good. Life is good. They have given us the equation. All right, so that's a good thing. It says M is going to represent the number of miles. So the miles driven. Ann drives for 290 miles. What is the cost of the rental truck? It says here the cost is given by this equation. So C represents the cost. So if I start using the equation they give us here, the cost, and then the parenthesis here, this is function notation, which is something we don't really talk about. But really what this is saying, it's not C times 290, it's the cost for the miles, or the cost for 290 miles is equal to 0.2 times the number of miles, which she traveled 290 or is going to, and then plus the 40. So basically, guys, all we have to do here is plug into this equation that they give us. That's why life's really good here. They gave us the equation to plug into. So there's nothing to do here. The cost for the 290 miles is going to be equal to whatever we get when we evaluate the other side of the equal sign here. So the cost for 290 miles is whatever that gives me. So let's do this calculation. Let's clear off here, and we'll go 0.2, or that's like 20 cents. 20 cents per mile. So 20 cents times the 290 miles. Calculator is going to do the order of operations for me, so I'm just going to put the plus 40 right in here. And I'm going to hit enter, and we are going to be at $98. So the cost for this rental truck for the 290 miles is a total of $98. All right, let's take a look here. Next example, Mike's Movers charges a flat fee of $200 plus $20 per hour. I am going to stop right there. Charges, all right, so the charge or the cost, let's call it C. The charge is what? Well, the charge is a $200 flat fee. What's a flat fee? That means it is a one-time charge, okay? So just to have Mike move their stuff, he's charging them $200 up front. Plus, it says, plus $20 per hour. So $20 per hour, and we don't use a variable that makes sense. We're going to say per H. So the charge for Mike is $200 up front plus $20 per hour. If one of their customers is charged a total of $260, so the charge for this customer, C, was $260. How many hours? So here's the question, what we're trying to answer. How many hours were they charged? Okay, so basically, how long did it take Mike to do this job? Well, here's the deal. We know that C is 260, and I can simply just take that value and plug it in here for C and solve. So I've got 260 is equal to 200 plus 20h. When you solve the equation, you're going to subtract the 200 on each side. Subtract 200 here as well. And when I subtract the 200, I've got 60 is equal to 20h. Well, we divide 20, and the number of hours, when I divide 60 by 20, the number of hours ends up being 3. So B is 3. Guys, as you're watching through the video here, by all means, pause it, take some notes. Also, good idea to maybe rewind if there's something that I go over a little too fast. Take a look at it again, see what I've got to say. Make sure that you're understanding how to do these. Take a look at the next one here. Lauren and Christy made a total of $20.60 selling cookies and lemonade. So the total they made was $260 selling cookies and lemonade. Their equation below describes the relationship between the number of cookies sold. So we know that the number of cookies sold is X, and the number of glasses of lemonade sold. So the glasses of lemonade sold is Y. Well, let's interpret this equation. Okay, 0.5, this is a number by a variable, so this is per X, or per cookie sold. Okay, so 0.5, what is that? 0.5 per cookie sold. It would probably make more sense to add a 0 there and say it's 50 cents per cookie plus 1.3, but we're talking about money. So this is going to be $1.30 per Y, and we know that Y represents the glasses of lemonade. So it's $1.30 per glass of lemonade equals 20.6. Well, that's that $20.60 they're talking about up here. So it was 50 cents per cookie sold plus $1.30 per glass of lemonade sold, and their total profit for the day at their little stand was $20.60. What did the two coefficients of 0.5 and 1.3 represent? Oh, we've already talked about this. 50 cents, $1.30. It is how much for a cookie and how much for a glass of lemonade. So Lauren and Christy sold cookies for 50 cents, glasses of lemonade for $1.30. Not a bad day on the lemonade stand for those kids, bringing in $20.60 into their piggy bank. All right, taking a look at our last one here. Megan completed her chemistry and geometry homework. Each chemistry assignment has X problems. So chemistry assignments have X problems. Each geometry assignment has Y problems. She must complete a total of 67 problems. The equation below describes the relationship between the number of chemistry problems and the number of geometry problems. So this is good. They gave me the equation. And then it says the ordered pair 716 is a solution. It is a solution. Okay, so 716 is a solution. So this is like an X value and a Y value. What does the solution of 7 and 16 represent? Oh, what does 7 and 16 represent? We already know that 7 represents X and 16 represents a Y value. And up here, they've already given me the answer in the problem. Each chemistry assignment has X problems. So this is X is the number of problems in a chemistry assignment. And each geometry assignment has Y problems. So that is the number, Y represents the number of problems in a geometry assignment. So I guess I could even call this C, comma G, chemistry, comma geometry. Let's see what it says. Does this ordered pair, that's what it's asking, what does the ordered pair represent? Does it represent Megan spent 7 minutes on her chemistry homework and 16 minutes on her geometry? No. It's the number of problems. Chemistry assignment has X problems, not minutes. Megan has completed 7 chemistry assignments and 16 geometry assignments. That's not it either, because this is saying X is the number of problems. So it's 7 problems of chemistry, 16 problems of geometry. So it's not the number of assignments. It's not the number of minutes. Each chemistry assignment contains 7 problems. Each geometry assignment contains 16 problems. That makes a lot of sense because X, that solution represents exactly that according to what the word problem is talking about. Megan must complete 9 more geometry assignments and chemistry assignments. No, that's definitely not the case either. So our final solution there is going to be C, and they pretty much gave the answer with the wording of the problem telling you what X and Y represent. Anyway, guys, after the video here, you're going to go ahead and get onto the island and do a section of 5A. I'm going to have you go under My Classes and do a set of assigned problems. I'm going to pick out the problems you're going to do to go along with the lesson that we talked about here today. Anyway, guys, have a great day and hope to see you online in the chat session.